Every time you open your eyes, you see things, similar things, different things. They make up the world that surrounds you. What you don't see, yet you think, is that those things that you see have causes. Like a basketball doesn't just fly through the air, it's mostly thrown by a player who gets it from another player. Causes often remain unknown. Even so, you know that they must be somewhere in the world that surrounds you. This idea can be translated into mathematics, which gives us a general formula of causality. It says that anything new is caused by the past. In 1853, an architect came up with quite a similar formula. He had seen a large world exhibition, the first of its kind. It was exciting. In most sections of the exhibition, people could see groups of similar styled items. The Chinese section was full of similar styled chinaware. Stylistic variants of some sort stood next to stylistic variants of other types. In the Tunisian section, even guidebooks were writing that there were many similar styled Tunisian red caps. Our architect was himself involved in the design of multiple sections of the exhibition. In the Canadian section, he hung up a canoe. But above all, he was fascinated to see styles and stylistic diversity everywhere. And he was fascinated to think that a cap, a cup, a vase, a canoe, there were reasons why they were shaped the way they were. Yet, where do creativity and diversity have a place in a general formula of causality? To understand that, we must further develop the formula, and it's only a tiny step. We insert plus signs. Rather than just saying that everything has causes, we now say that everything has causes that add up. We have now transformed our initial formula of causality into a general formula of creativity. But really? Why? In the broadest sense, creativity always transforms one thing, x1, into another thing, x2, and this is exactly what we are now modeling. What is immediately evident is that such creative flows make items closely interrelated. Change x1 and you have an immediate effect on x2. x1 and x2 are family. If you now insert more variables, you see that they form larger and larger groups of closely interrelated things. I call these groups creative groups. They are a result of creativity. You can also think of these groups as big families, lineages, or groups of stylistic variants. There is a second thing that we can also do with our initial formula. If we insert multiplications instead of additions in it, we receive a general formula of interplay. This formula can be used to explain the rise and fall of fashions, the return of fashions, and the formation of diversity. Our fellow architect could have used it to explain the diversity of styles that keeps fascinating us. And his fellow ecologists could have used it to explain the diversity of life on Earth. But the origin of this formula is physics, where this type of equation was first developed to calculate the orbits of planets. In any field of study, when you open your eyes, you see things, similar things, different things. You think that they have causes and that there is creativity and diversity. The idea that plus signs are for creativity while multiplication signs are for diversity makes most intuitive sense when you think of these operations in their most basic geometrical terms. In geometry, additions are for adding line to line to create longer lines. The lines remain lines. By contrast, multiplications turn lines into planes and planes into spaces. These properties are maintained in more advanced causal modeling. Additions are for creativity. They turn small creative steps into big creative steps. They form creative groups and they extend lineages. By contrast, multiplications are for diversity. They are used to model the interplay between lineages. Each multiplication adds a lineage, it adds a new dimension. This turns lines into planes, and it turns planes into spaces. And we do think of cultures, societies, cities, ecosystems as diverse things that have many dimensions that interact.